Hello guys, welcome to this video, and for a final time we're going to be solving a practical problem on error. So we are giving this complicated looking problem. We're giving W to be 4.52 plus or minus 0.02 cm, A is 2.0 plus minus 0.2 cm, Y is 3.0 plus minus 0.6 cm, and we are asked to find Z equal to wy square over square root of a. So how exactly do we go about that? So in asking you to find z, they want you to find z like this. So let z be in this form, z plus or minus delta z. Okay, so remember that all we just need to do is to combine all we've learned so far, all we've learned about addition, distribution of errors in powers, subtraction and distribution. Please, if you've not watched those videos, check the playlist and watch all of them so that you get conversant. But how do we evaluate this? So my z is actually just imputing the values, that's the measured values of all these quantities into this particular formula. Then my delta z, I'll show you how to solve it. So to get z, all we just need to do is to evaluate wy squared over the square root of a. And to do that, our W is 4.52. So I have 4.52. Then my y square is a 3.0 all square divided by square root of a. Square root of a, and the square root of a, as you can see, is square root of 2.0. And if we evaluate this, let's say we use our calculator to help us. So we have this ratio, 4.52 times 3 squared, divided by square root of 2. So 28.7651. So z is 28.7651. Now this is the measured value we'll get when we determine z. Now let's try to find the absolute error in z. Now to find the absolute error in z, first of all, start with the relative error in z. How do you start with the relative error in z? Remember that z is already defined to us according to this formula, wy squared over square root of a. Now if I translate this, it's still the same thing as you having z is wy squared over a raised to the power of half. Is that okay? So now let's determine how the relative error in z will look like. Of course, relative error is less or equal to, then for w, remember we have 3 components here, so my relative error will consist of 3 summed components. For w, I'll have the relative error in evaluating w, then plus. Now for y, I'll have the relative error in evaluating y. It's just that because of this power 2, the result will be multiplied by 2, and the same thing will happen for a. I'll have the relative error in evaluating a, but because of this half, my results will be halved like this. Okay, so this is how to determine relative error, and this is just an application of what we learned in the last video about propagation of error in powers plus propagation in addition, division, multiplication, and subtraction basically. So these ones are just multiplication and division, then and powers. So we can evaluate our relative error delta z over z to be our w is 0.02. We have 0.02 over w being 4.52, then plus 2 multiplied by, we have for y I have 3 and 6, so I have 0.6 divided by 3, and finally I have 1 over 2 into a. Delta a is 0.2 and a is 2. 0.2 divided by 2. So remember that z is going to take on the units of whatever this division is, so I guess we'll just have to work with that quantity over there. Don't worry, we'll get the units later. So let's get the relative error first. So I'm going to use my calculator to help me get my relative error. So in the first ratio I have 0.02 divided by 4.52 plus the second ratio I have 2 times 0.6 divided by 3. Okay, and third ratio I have 1/2 times, or which is still the same thing as 0.5 times 0.2 divided by 2, and this evaluates to 0.4544 2477876. So my relative error is taken as 0.4544 2477876. So this is my relative error. Now if I want to find my absolute error, I like using this symbol for relative error. Absolute error, which is delta z, can be gotten when you multiply relative error times z. Remember, you've already computed z, and when you computed z, this is the value that you got, 28.7651. So you have your absolute error to be this whole value times 0.454424777876 times 28.7651. So our absolute error is going to be, let's just evaluate this. So we have 28.7651 times 0.44247776. So we have 13.07157. So 13.07157. So this is the absolute error in measuring the quantity z, so that my z plus or minus delta z can be replaced as 28.7651 plus or minus, let me say 13.07157. okay, thereabout. So this is the evaluation of this long stuff we just saw here, using all that we've learned. And if I want to be strict with the evaluation of the units, since 3 of them are in units and in centimeters, so W is cm, then I have cm squared all over cm to the 1/2. So I'll have cm cube divided by cm to the 1/2, which is cm to the what? 3 minus 1/2 is what? 5/2. So that will be the unit of z. So z will be a unit such that it is cm to the 5/2, like that. So if there's anything like that, I guess that does it. So the only thing that makes sense was, okay, I think I made a mistake. Assuming here is square because it looks like area. So if it's square, then I'll now have this one to be square root of something square is just 1. So just 1. Then you now have cm cube divided by cm, which is cm squared. So the final answer is also a squared. Okay, I think I made a mistake when I was taking note of the units of So the values that have units is the final value, then the absolute value also have a unit. It's all going to be in centimeter square, but the relative error is dimensionless. So with this, we've come to the end of errors. So this is a practical problem solved, and I hope that you'll be able to take on any problem that you're given. So good luck out there, guys.